Still working in section 9.1 today, going over the basics of test of significance. There's so much for you to keep track of. I really want you to focus on this intro stuff because it'll help set the stage for everything later. So in the last video, we focused on writing the hypotheses. In this video, we're focusing on the p-values and significance level. So we're basically going from the very beginning of your test of significance to the very end of your test of significance. So if the p-value is low, you're going to reject your HO. Easy way to remember it, p-value low, reject HO. What that means is that you have convincing evidence for the alternative hypothesis. If the p-value is high, you're going to fail to reject the null hypothesis. So if p-value is high, you're going to fail to reject the HO, which means you do not have convincing evidence for the alternative hypothesis. My biggest suggestion when dealing with these tests of significance is to relate it back to a court case. In a court case, it's the lawyer's job to prove the person, the defendant, is guilty. Is there enough evidence to prove their guilt? Or is there not enough evidence? Remember, we always in a court case either find someone guilty or we find them not guilty. We never say that they're innocent. So just like in our hypothesis that we talked about earlier, we either reject or we fail to reject. We're never saying innocent, we're never accepting the alternative hypothesis. If we're saying guilty, or in our case, if we're saying to reject the null, that means that there is enough evidence to say that something happened here. And if there's not, in the not guilty case, that's the same thing as us saying that we're going to fail to reject. It doesn't mean that the alternative isn't true. It doesn't mean that the null hypothesis is true. All it means is that we don't have enough evidence to say otherwise. So when the p-value is less than the alpha level, we have statistically significant evidence to reject the null hypothesis. The alpha level is basically your barrier. It's your gauge. If it's above or below the alpha level is what tells you whether you're going to reject or going to fail to reject. It sets that stage for you. It sets the bar that you're testing everything against. The significance level must be set at the same time you write the hypotheses, before you conduct the study or gather any data. Now, an easy way to manipulate statistics, as a lot of you guys probably know that people do, is to set your alpha level at the very end, because then you can set it according to what you want. If I conducted a study and I wanted in the end to reject the null hypothesis, I can wait around to see what my probability is, what my p-value is, and at that point I can then set an alpha level high enough or low enough, whichever way it is that I'm trying to do it. If I'm trying to reject, then I would set it low enough so it's going to be below that p-value. Or if I'm wanting to fail to reject, then I just set my alpha level just above that and I can say that I can fail to reject. So if you're going to honestly do a test of significance, it should be set in the very beginning at the same time you set your hypotheses. So let's go through a couple of examples so we see how this works out. So we're going to revisit the example from before in the first video about the Jordanian children. For that study, the sample mean hemoglobin level was 11.3. I think that those were grams per deciliter, and the sample standard deviation was 1.6. A significance test yields a p-value of 0.0016. If an alpha level of 0.05 was set, what would your conclusion be? Now we always test our p-value against our alpha level. Remember, if the p-value is low, we're going to reject our HO. So 0.0016 would be 0.16%, so below 1%, and our alpha level of 0.05 is a 5% alpha level. 0.0016 is definitely below 0.05. So that would have us make our conclusion. With a low p-value of 0.0016, we reject the null hypothesis in favor of the alternative. Thus, we have statistically significant evidence to suggest the true mean amount of hemoglobin in Jordanian children is less than 12 grams per deciliter. And another example for this. For Yvonne's survey, remember that was the one about whether or not you argue with your friends? 96 students in the sample said they rarely or never argue with friends. A significance test yields a p-value of 0.0291. What conclusion would you make if alpha was equal to 0.01? So we're going to take this p-value and we're going to judge it against this alpha level. 0.0291 is nearly 3%, which is definitely greater than, let's It's definitely greater than 1%. So when our p-value is high, we fail to reject. So with the p-value of 0.0291, which is higher than our alpha level of 1%, we fail to reject the null hypothesis in favor of the alternative hypothesis. Therefore, we do not have statistically significant evidence to suggest the true proportion of teens in Yvonne's school who rarely or never argue with their friends is not equal to 72%. So remember what I said in the very beginning of the video. Our last video, 9.1, was about the hypotheses. Writing the hypotheses is going to set up everything for our problem. It's one of the very first things we do in a test of significance. Now here, these are writing our conclusions. This is the way a complete conclusion should look. The way the wording is here is very similar to the way you should be writing it when you're writing your conclusion. So now we've established how to begin a test of significance and how to end a test of significance. Everything that we do in the next sections will be to fill in that middle ground. What do you do as far as the calculations go?